أعزائي الطلبة طلبة الثانوية العامة قسم اللغات، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس الألجبرا. General Exercises on Complex Numbers Part 2. Question 8. Prove that one of the values of the expression root I minus root negative I equals root 2. Let z1 equals I and I equals cosine pi over 2 plus I sine pi over 2. The position of I indicate that its modulus equal 1 and the angle between the complex number I and the positive direction of x-axis is 90. So z1 equals cosine pi over 2 plus I sine pi over 2. We want to calculate root I, square root of I. Actually we have two square roots. Substituting r equals 0, we get the first root, and substituting r equal 1, we get the second root in this form, cosine theta plus 2r pi over k, such that k is the number of roots. What is the number of roots? It's 2, because we will calculate square root. The required is square root, so we have 2 roots when k equal 2. And r, we substitute r equals 0 once, and another once you substitute r equal 1 as follows. When r equals 0, we get the first root. So root z1 equals cosine pi over 2 plus I sine pi over 2. When you substitute theta equal pi over 2 like this and substitute r equals 0, so this part will be equal 0. So we have cosine pi over 2 all over 2. Cosine pi over 2 all over 2. It is pi over 4. And you know that pi over 4 equals 45 in degree measure. So cosine pi over 4 equals 1 over root 2 plus I sine 1 over root 2. I as sine pi over 4 equals 1 over root 2. Sine pi over 2 all over 2, it's equal sine pi over 4 equals 1 over root 2. And this is the first root. Second root, when substitute r equal 1, we get the second root. Root z1 equals cosine pi over 2 plus 2 multiply 1 multiply pi all over 2. We substitute r equal 1 all over 2 plus I sine pi over 2 plus 2 by 1 by multiply pi all over 2. When you simplify this part, you get 5 over 4 pi. And it's easy to convert pi to 180. So you will have cosine 5 over 4 multiply 180. You can write it easy on your calculator. Then you will get negative 1 over root 2 plus I sine 5 over 4 multiply 180. You will get negative 1 over root 2i. So this is the second root to root I. This is the second root. Now we calculate root negative I. First we write negative I. Negative I equals cosine negative pi over 2 plus I sine negative pi over 2. As in the figure, negative I equals cosine negative pi over 2 plus I sine negative pi over 2. Of course we have two square roots. We'll get it substituting r equals 0 and another time r equal 1. So root negative I equals cosine negative pi over 2 plus 2r pi over 2 plus I sine negative pi over 2 plus 2r pi all over 2, and r equals 0 and 1. Substituting r equals 0 in this form, you will get cosine negative pi over 4 plus I sine. Also substitute here r equals 0. So the angle, it will be negative pi over 4. As we said before, consider pi equals 180. So you have cosine negative 180 over 4 equals 1 over root 2. And the I sine negative 180 over 4 also equal negative 1 over root 2 I. Now we get the second root to z2. Substituting r equal 1. What you get? Cosine negative pi over 2 plus 2 multiply 1 multiply pi all over 2. Considering pi equals 180, what you get? You get negative 1 over root 2 plus 1 over root 2i. And this is the fourth form. From 1 and 4, by substituting, root I equals 1 over root 2 plus 1 over root 2 minus the fourth root, it is negative 1 over root 2 plus 1 over root 2i. Now 1 over root 2 minus 1 over root 2i, again 1 over root 2i minus 1 over root 2i equals 0. So we have 1 over root 2 plus 1 over root 2 equals root 2. And this is the required. What is the required? Root I minus root negative I equals root 2. One of the value of this expression equals root 2. Question 9. If absolute, or you can say modulus of z1 equals the modulus of z2 equals 1, and the arg of z1, z3, z2 power 3 equals 81, and the arg of argument, it is the amplitude of z1 over z2 equals 33 degrees. Write in the form of x plus yi, it is the Cartesian form, the number z1 power 15 plus z2 power 15. First, we must calculate the amplitude of z1 and z2. Let theta 1 is the argument or amplitude of z1 and z2 is the argument of z2. Argument of z1, z2 power 3 equals theta 1 plus 3 theta 2. It's equal 81. Theta 1 minus theta 2 equals 33, as argument of z1 over z2 equals theta 1 minus theta 2, and theta 1 minus theta 2 equals 33. So we have theta 1 plus 3 theta 2 equals 81, it is equation 1, and theta 1 minus theta 2 equals 33. Theta 1 minus theta 2 equals 33. It means theta 1 equals 33 plus theta 2. From 1 and 2, by substituting, what we get? You substitute theta 1 by 33 plus theta 2, as in this equation. 33 plus theta 2 plus 3 theta 2 equals 81. So theta 2 plus 3 theta 2 equals 4 theta 2, and 81 minus 33 equal 48. Dividing both sides by 4 to get theta 2 equals 12. And from 2 we can get theta 2 equals 33 plus 12, which equal 45. In 2 here we have theta 1 equals 33 plus theta 2, but theta 2 equals 12, so 33 plus 12 equals 45, and theta 1 equals 45. So Z1 equals cosine 45 plus I sine 45, as theta 1 equals 45, and Z2 equals cosine 12 plus I sine 12. Don't forget theta 2 equals 12, so Z2 equals cosine 12 plus I sine 12, and theta 1 equals 45, so Z1 equals cosine 45 plus I sine 45. The required is Z1 power 15 plus Z2 power 15. So first we calculate Z1 power 15. Z1 power 15 equals cosine 45 plus I sine 45 all power 15 equals cosine 45 multiply 15 equals cosine 675. Also sine 45 power 15, it means sine 45 multiply 15, which equal sine 675. On your calculator, cosine 675 equals 1 over root 2, and sine 675 equals negative 1 over root 2i. With respect to Z2 power 15, we write in this form cosine 12 plus I sine 12 all power 15. To find this result, we write cosine 12 multiply 15 equals cosine 180. I sine 12 multiply 15, it is the power, equals sine 180. Cosine 180 equals negative 1, and sine 180 equals 0. Of course, 0 multiply I equals 0, so the result equals negative 1. But the required, again, Z1 power 15 plus Z2 power 15, so we have to add 1 over root 2 minus 1 over root 2i plus negative 1. So what we have, Z1 power 15 plus Z2 power 15 equals 1 over root 2 minus 1, it is the real part, minus 1 over root 2i. Here we collect the real parts, 1 over root 2 minus 1. 1 over root 2 minus 1, it is the real part. Minus 1 over root 2, and this is the imagined part. Question 10. Find the roots of the equation z power 4 plus 4 equals 0 in the trigonometric form. How many roots for this equation? We have 4 roots. Z power 4 plus 4 equals 0 implies that z power 4 equals negative 4. Negative 4 in this diagram lies on the negative part of x-axis, so the measure of the angle equals 180 degrees or pi in the radian measure. So negative 4 equals 4 cosine pi plus I sine pi. Z equals 4 cosine pi plus I sine pi all power 1 over 4. So Z equals 4 power 1 over 4, and you can write 4 as root 2 power 4. So we have root 2 power 4 all power 1 over 4, which equal root 2, and cosine pi I sine pi all power 4, we write it here. So how many root we have? We have, or we must calculate 4 roots on the form cosine pi plus 2r pi over 4 plus I sine pi plus 2r pi over 4. Don't forget that 4, it is the number of roots, and r, it will take the values 0, 1, 2, 3. How many roots? 1, 2, 3, 4 roots according to the value of r. When r equals 0, z1 equals root 2 cosine pi over 4 plus I sine pi over 4, and we will not make any change on this root because theta is pi over 4 and it's included between negative pi and pi. When r equal 1, z2 equals root 2 multiply cosine pi plus 2 pi over 4. We substitute on this form. We substitute theta equal pi, and we substitute r equal 1. So multiply 1 equal 2 multiply 1 multiply pi equals 2 pi. So we have 3 pi over 4 plus I sine 3 pi over 4, which equal root cosine 3 pi over 4 plus I sine 3 pi over 4, and the amplitude of this complex number included between negative pi and pi. So we'll take it. When r equal 2, z2 equals root cosine 5 over 4 pi plus I sine 5 over 4 pi, after we substitute r equal to in the general form. But 5 over 4 pi, it's greater than pi, so we subtract 5 over 4 pi minus 2 pi in cosine and sine. So 5 over 4 pi minus 2 pi equals negative 3 over 4 pi, and this is the principal amplitude. It's included between negative pi and pi. So this root equals root 2 cosine negative 3 over 4 pi plus I sine negative 3 over 4 pi, and we'll take it as one of the four roots. When r equal 3, as the previous, we write z3 equals root 2 cosine 7 over 4 pi plus I sine 7 over 4 pi. Also, we can subtract 2 pi because 7 over 4 pi not included between negative pi and pi. So the root equal root 2 cosine 7 over 4 pi minus 2 pi plus I sine 7 over 4 pi minus 2 pi. and 7 over 4 pi minus 2 pi equals negative 1 over 4 pi. So the final form will be root 2 cosine negative 1 over 4 pi plus I sine negative 1 over 4 pi. 11. Question 11. If z equals sine pi over 9 plus I cosine pi over 9. Find z bar in the trigonometric form and find the cubic roots of the number z bar power 9. Z equals sine pi over 9 plus I cosine pi over 9. First, we calculate z bar. Z bar, it is the conjugate of z. It is the same number with some changes. We change positive to negative. So z bar equals sine pi over 9 minus I cosine pi over 9. To put z bar on its standard form, we convert sine to cosine by subtracting pi over 2, as cosine pi over 9 minus pi over 2 equals sine pi over 9. To convert from sine to cosine, you add or subtract pi over 2. In this case, because the conjugate of z bar lies on the fourth quadrant. So we subtract pi over 2. So sine pi over 2 equals cosine pi over 2 minus pi over 2 plus I sine pi over 9 minus pi over 2. So z bar equals cosine negative 7 over 18 pi. After you simplify these two numbers, pi over 9 minus pi over 9 equals negative 7 over 18 pi plus I sine negative 7 over 18 pi. And z bar power 9 equals the same number, all power 9. So z bar power 9 equals cosine negative 7 over 2. How we get it? Multiplying the power by the value of the angle. So 9 multiply negative 7 over 18 pi equals negative 7 over 2 pi plus I sine negative 7 over 2 pi. Negative 7 over 2 pi not included between negative pi and pi. So you have to add 2 pi. In this case, we add 2 pi to get half pi plus I sine half pi. The cubic roots equals cosine half pi plus 2r pi over 3 plus I sine half pi plus 2r pi over 3. The second required here is to find the cubic roots of z bar power 9. How you get it? Z bar power 9. How you get it? The cubic roots equals cosine theta plus 2r pi over k. K equal 3. 3 is the number of roots. And the r, it will take the values 0 and 1 and 2. The cubic roots, once more, equals cosine half pi plus 2r pi over 3 plus I sine half pi plus 2r pi over 3. And the r equals 0, 1 and 2. When r equals 0, then z1 equals cosine 1 over 6 pi. Substitute r equals 0 here. What you get? It's 0. 0 plus half pi over 3 equals 1 over 6 pi plus I sine 1 over 6 pi. Now substitute r equal 1. Then z2, it is the second root, equals the cosine half pi plus 2 pi over 3 plus I sine half pi plus 2 pi over 3. It's equal cosine 5 over 6 pi plus I sine 5 over 6 pi. 5 over 6 pi included between negative pi and pi, so we'll take it as a principal amplitude. When r equal 2, then z3 equals cosine half pi plus 4 pi over 3. Substituting r equal 2 in the general form, plus I sine half pi plus 4 pi over 3, it's equal cosine 3 over 2 pi plus I sine 3 over 2 pi. But this is not included between the interval negative pi and pi, so we have to subtract negative 2 pi. So after subtracting, z3 equals cosine negative 1 over 2 pi plus I sine negative 1 over 2 pi. Question number 12. If z1 equals 6 plus 4i plus 1 plus I and z2 equals 26 over 5 minus I, if z equals 4, z1 minus z2, find the cubic roots of z in the exponential form. Of course, first we convert z1 to its simplest form, multiplying up and down by 1 minus I. So multiplying 1 up and down by 1 minus I, what you get in the denominator, it will be 1 plus 1. As 1 plus I multiply 1 minus I equals 1 minus I power 2. But I power 2 equals negative 1, so the result will be positive 1. So the final result to the denominator equals 2. 6 multiply 1 equals 6. 6 multiply negative 1 equals negative 6. 4i multiply I equals 4i. 4i multiply negative I equals positive 4. As I multiply I equals negative 1. So the result will be positive 4. 6 plus 4 equals 10. Negative 6i plus 4i equals negative 2i all over 2. 10 divided 2 equals 5. Negative 2i divided 2 equals I. Z2 equals 26 over 5 minus 5 minus I multiply 5 plus I over 5 plus I equals 5 plus I. So Z equals 4 multiply Z1 minus Z2. All you have to do is to substitute. Substituting Z1 equals 5 minus I and Z2 equals 5 plus I. 5 minus 5 equals 0. So we have between brackets negative I minus I equals negative 2I. So we have 4 multiply negative 2I equals negative 8I. It is 8 cosine negative pi over 2 plus I sine negative pi over 2. So this is the final form of Z. Then we find the cubic roots of Z in the exponential form. Of course, we have 3 cubic roots. So cubic root of z equals 8 multiply cosine negative pi over 2 plus I sine negative pi over 2 all power 1 over 3 because we'll get the cubic roots. Of course, cubic root of 8 is 2, and here we have cosine negative pi over 2 plus 2r pi over 3, considering r equals 0, 1, and 2. When r equals 0, z1 equals 2 cosine negative pi over 6 plus I sine negative pi over 6. In the exponential form, z1 will be 2e negative pi over 6i. This is the exponential form of the first root. When r equal 1, z2 equal 2 multiply cosine negative pi over 2 plus 2 pi over 3. So the angle will be pi over 2. And z1 and z2 equals 2 cosine pi over 2. After simplify, we get 2 cosine pi over 2 plus I sine pi over 2, and its exponential form will be 2e power theta I, and the theta equal pi over 2. So the exponential form of z2 is 2e power pi over 2i. When r equal 2, we get the third root. It will be 2 multiply cosine negative pi over 2 plus 4 pi all over 3 plus I sine negative pi over 2 plus 4 pi over 3 equals 2 cosine 7 over 6 pi. When you simplify this part, it will be 7 over 6 pi. You can write in your calculator negative half plus 4 all over 3. What you get? You will get 7 over 6. And we write pi. 7 over 6 pi not included between negative pi and pi. It is not the principal amplitude. So to convert it to principal amplitude, you subtract negative 2 pi. It will be 2 cosine negative 5 over 6 pi. So we have z3, it is the third root, equals 2 cosine negative pi 5 over 6 pi plus I sine negative 5 over 6 pi. In the exponential form, it will be 2. It is the modulus of the number, the complex number z. The modulus equal 2. The modulus equal 2. So it's equal to e power theta I. What is the value of theta? The value of theta, it is negative 5 over 6 pi. So the final result will be 2e negative 5 over 6 pi I. بكده بنكون انتهينا من general exercise 2 on the set of complex numbers. بتمنى ان انتوا تكونوا استفدتوا بكل دقيقة معايا، واللي عنده اي تعليق مفيش مانع ان يكتب كومنت، ولو حابب تتابع الدروس الجاية اعمل سبسكرايب للقناة. والسلام عليكم ورحمة الله وبركاته.